Hey, what's up, Algebra 1? Catlin here helping you out. We had two lessons to knock out today because we did a little 2-for-1 day lesson action in class. So we're going to hit lesson 7 and lesson 8 on your homework. And lesson 7 is kind of a repeat of what we did in class yesterday with these factored to standard forms, trying to figure out these little number puzzles. And the only thing we added different to it today is that we're going to have some negatives involved and the constant. All right, so if you look at 3 and 4 here, you can see that the constant is negative. And what we learned today in class, that if the constant is negative, then in your factor, you're going to have this plus minus mix. Because if you have a plus minus mix of factors like this, and we know that the two numbers that are multiplied here give us the constant. If one of them is positive and one of them is negative and you're multiplying, the constant is going to have to come out negative. So like in this first example here, 1 and negative 17 are going to get multiplied, and that's got to be a minus sign because that's going to give you negative 17. And we also found out that when they're mixed like this, it can make the adding a little more complicated because when you add these two things, negative 17 plus 1, we're getting 16, right? Because negative 17 and 1 combine to make 16. But the negative is winning the absolute value, so it wins the sign. And that's kind of what we're determining here is that the sign is going to be negative 16 because negative 16 plus 1 is negative 16. All right. And so if we swap those, as we see in number 2, if the minus goes to the 1 and the plus goes to the 17, we're still going to get a negative 17 when we multiply because it's still a negative times a positive. But when we add these together, now the 17 is going to win the absolute value battle, and it's going to win the sign, and this one's going to lose. And so this 16x is now going to become positive. We saw that whenever we practiced those in class. And so let's do that in reverse and look at number 3 here. We know that we have a negative constant, so we got plus minus. It's going to alternate. And what we need are two numbers that can multiply and give us 28, right? And can add or subtract together and give us 3. So what I told you guys to do to help on this was to list out all the factors of the number that you're trying to get, right? You can get 28 in a couple of different ways. You can get it with factors of 1 times 28. You can do it with 2 and 14. And you can also get it with 4 and 7, right? Those are like all of the ways that we can get the number 28 when we multiply, right? All of these multiply out and give us the 28 that we need to be in the constants place in standard form, right? And since it's a negative 28, we know that one of them's got to be positive and one of them's got to be negative. So whenever we add them together, they're actually going to subtract their absolute values. So we really need a pair of them that have a difference of our number in the middle, our linear term, which is 3. So out of these 3 pairs, which ones have a difference of 3? That's going to be this one, right? 7 minus 4 is 3. So these are the two that we want to pick. Now, whenever we choose which place to put the 4 and the 7, we have to be aware that we want the positives to win because this is positive. So we want 7 to go here and 4 to go in the minus place. That way, when we add 7 plus a negative 4, we get positive 3. And I know that's a lot to take in, but we've practiced a bunch of these. We're going to get some more practice this week. Don't flip out if you're struggling. There's going to be more time, okay? Let's look at this last one. We've got a negative to end, right, 28, and we're ending up with negative 12. So we need like a combination that has a difference of 12, and we want the negative number to definitely be winning here. So looking at our 3 sets for this one, right, the one that wins this take is going to be the 2 and the 14 because they have a difference of 12. And we want this to be negative 12, so we want the 14 to accompany the negative number so it wins that sign. So we definitely want the 14 to be subtraction, and we want the 2 to be the addition because 2 times negative 14 would give us the negative 28 that we need, and the negative 4 and the 2 added together would give us the negative 12 for the linear term that we need. I hope that's helpful for that one. I'm going to move on to the next step, which is lesson 8. We started to look at these special cases where we have these squares that are differenced in our expression. So these are all standard form. All right, we have a square subtracted by a square subtracted by a square added by a square, not what we're looking for, and a square subtracted by a square. All right. We noticed that whenever we have these two differences of squares, that they always came out in this form where their factored version would be an x plus and an x minus combo. But since they're squares, the parts that are in the factors are identical numbers. They're just one's a plus and one's a minus. So, like for this one, sorry, I wrote x. I should have wrote a. My bad, because they were using the letter a there. All right, so for this first one, we got A plus and A minus, and we have to ask ourselves. This really relates well to our 8th grade lesson today too, for the kids that are on my team. What number can I multiply by itself to give me 36? And that number is 6. So we found out that these essentially you take the square root of the number that's ending and the square root of a squared, and you just multiply them, one positive and one negative. Because what we found out what happened was when you multiply the 6 and the negative 6, you're getting the negative 36. But when you add the 6 and the negative 6 to get the linear term, they're additive inverses, and there is no linear term, which is why we're lacking the linear term here when we write it out. And the same thing happens here on number 2, but the order is important. Okay, the order of this is really important. So we're always going to have these two numbers get multiplied out in the factored form. Okay, they're going to equal these. But the order in which they were written is important. So this one's going to start with the 7 because that's the square root of 49. All right, and there's a difference. So we're going to have this plus minus combination like we've been seeing with these. And we need this b term to be negative. Right? So for that to be multiplied and get negative, you got to have a combination of one being added and one being subtracted. And what's the square root of 25? Well, that's 5. And we got to have our b there, so 5b. And we write that here. It's identical, right? They're kind of like twins. The only difference between the two factors is a plus minus. And we've got to have that plus minus combination to get a negative result when we multiply the last terms. So this only works when we have that taking place. 5b times 5b is 25b squared. 7 times 7 is 49. Now, I mentioned earlier when I was talking about this that this third one doesn't really fit this mold, okay? And I want to go into a little bit more explanation of why it doesn't work. Some of you are trying to write, c plus 3 and c minus 3. I want you to think about this one for a second. If we diagram this one out, if we diagrammed it out, and we wrote down what was getting multiplied here. All right. A lot of you guys are saying c minus 3 and c plus 3. Well, if you do that, you get c squared, you get negative 3c, and you get 3c, and you get negative 9. You don't get positive 9. There's no way that you can get a positive 9 there. In fact, if you think about what that parabola looks like on the graph, okay, at 1, 2, 3, 4, 5, 6, 7, 8, 9, there's your vertex, and there's your parabola opening upward because it's positive. This is never going to cross the x-axis. It doesn't even have x-intercepts for us to find and factor out. This one is not even possible to do, right? I mean, you think about it. What we're trying to get here is we're trying to get factors that will make these disappear and that be positive. Now, you tell me how I could make that happen, because I can make 3 times 3 be 9 all day. But if that one's positive and that one's positive, that makes that positive, and that's going to give me a middle linear term of 6c, right? There's no way for this to actually factor out and be possible. So there's no way for that to take place. Now, the last one, the fractions gave you guys a little bit of a headache in the beginning, but these aren't bad. Look at the parts of the fraction, because those parts, the numerator and denominator, are really nice numbers. They're perfect squares. 10 times 10 is 100, and 9 times 9 is 81. So if I'm looking for a number that can multiply out and give me that, the number that I'm looking for is just 10 over 9, 10 ninths. Don't overcomplicate it and try to change that to a decimal. Okay, don't make this 1 and 1/9 or 1.1 repeating. You're just going to make it confusing on yourself. It's 10 over 9. Okay, and since it's a difference of two squares, one of them is going to be adding, right, and the other one is going to be subtracting. And we just need the square root of the other one. The square root of 16 is 4, and the square root of d squared is d. So 4d and 4d. And there we go. Those are your equivalent versions in factored form, and the third one is not possible. we will get more practice with this. These are special cases. This only happens when your standard form is the difference of two squares. All right? It's got to be the difference of two squares, and it's got to be the squared term and the constant term. The linear term can't be part of this. All right? So it's a special case that we're looking for. It doesn't happen very often. All right? So don't get it mixed up. It's only a special case that happens from time to time. All right? And that's all I got for your video today. I'll see you guys tomorrow in class. Don't forget homework due Friday and a quiz then too.